Sure. Hi everyone, I'm Ankit. I am a customer engineer, which is a solutions architect at Google, and I focus on data and analytics. So I work with customers on helping them design and architect and even implement their big data platforms on Google Cloud using both open source technologies and the technologies that Google Cloud has. And of late, I have started doing a little bit of AIML as well. I mean, I, I'm not a PhD in AIML and I don't have formal education, but talking to a lot of customers and talking to a lot of solution architects, there are a few things that I have learned that I would like to share with you guys. But my major focus areas and customer interactions are usually on the big data, data modernization on cloud portions. And I wanted to speak with you all today because uh, I think that I can share where I started my AIML journey from, being a citizen data scientist and not someone who's highly specialized in all these models and stuff like that, but still make a little bit of progress. And then once we graduate this stage of talking about models and at least understanding how we can use some of the tools that Google has, then taking it to the next level of actually the whole productionization of these models and utilizing them at scale for your use case. So I thought talking to you about the starting of how these projects usually start, which is simple, then complex, would be useful, and how you can, if you're using GA and if you're not using it, how you can use it to sort of turn it into something a little more meaningful than it actually is in its raw form. So I thought those could be some good use cases to talk about, and and then take this conversation forward to some follow-ups like, hey, I already have these models. How do I productionize them at scale? Like, how do I do the ML ops piece and stuff like that? That's not going to be the focus of today's conversation, but I would love to sort of engage into those conversations as well as follow-ups to this. So that was my intent to come here and talk to you guys. And I personally feel that this use case is one of the easiest and the simplest use cases to start off with on the AIML stack with respect to marketing, because what we are going to do today is essentially run some SQL queries that would create AIML models for us in BigQuery. So of course there is some amount of theoretical knowledge that's needed on what kind of models I should create and stuff like that. So don't worry about all that for today. We'll just go with the flow and talk about how syntactically simple it is to create these models, and then also I also want to learn from you guys on how you do marketing, how you interpret that data in your own organizations, and how some of this can be juxtaposed with that understanding to see if we have some synergies there. So that's the agenda. Does anyone have any questions before we start? Any curiosity questions or anything about me or Lance? I mean, by the way, I'm from Seattle. I mean, I moved from Vancouver to Seattle like 3 months ago. So I work out of the Seattle office, and this is my first time to Hawaii. So it's all positive experience till now, as I would say. Yeah. Any questions before we start on the agenda or the context or anything that in particular with this event, or if not, that's fine too. Any other questions?
Maybe quick show of hands, like how many of you are using GA, right?
Okay.
And then just in terms of maybe any experience or familiarity with using, a model and doing any data analytics off of it.
Cool. All right. So this is the agenda. So we will try to use two kinds of models. One is a logistic regression and one is clustering. We'll go over those, a little bit of theory as well. But the primary goal will be to get you started on the syntax and have you try to interpret that in your marketing knowledge and lingo and see if those would be useful, and then talk to you about how you can, and learn from you how your use cases can be used to sort of refine this approach as well for your organization. Just three things logistically that I would love to get your confirmation on. I emailed a code repository that's in Git to all the registrants. By any means, did you all receive that email? Okay. So that email contains a link to the repo. So if you guys want to open that, because we are gonna use that to run our code in BigQuery, that's gonna be step number one. Step number two is, before I sent that email, there would have been another email requesting you to confirm your access to the project, the Google project that I sent over. I think sometimes that behaves well and sometimes it doesn't. If there are any accounts that are not really tied to Workspace or something like that, you might not have gotten that email. So in that case, I would request you to give me your Gmail if that's okay, and I can add that to my project. So we'll wait for 5-10 minutes for everyone to settle in on that note and then get started. But I'll probably come down and ask you all if you have access to the project that I added you to. And once we get to that, then we will go into the BigQuery console and request everyone to create a simple data set for their models so that everyone sees their models. You can see everyone else's model as well. That's not an issue, but it will be easy for you to segregate your work from others and monitor that. So we'll go over that, but have everyone gotten into the project with the email that I sent for the access? If okay.
I'll send you my Gmail.
Okay, thank you. Let me actually come and talk to everyone and see if they can get into the project for a minute. Oh, so you don't have a laptop? Okay, that's okay. We can just follow along there. That's okay. Hey, you are in the project? Awesome. You should be in the project as well. Yep, so this is the first email, and then you should have gotten another email as well.
Yes.
Okay, awesome. AVDF, yeah, that's perfect. Thank you. You are in the project as well. Thanks
Yes.
for confirming. All right.
Is there a place to create a name?
No, so actually, that project already contains my name.
Uh-huh.
So you just need to, yeah, AVDF. That's all. That's all you need to
Okay,
be.
thank
That's
you.
all. So, hey, you also seem to be nice. Thank you. Hello, you seem to be in the project. Thank you. And if you want to give me your Gmail on any of this, that would be.
Emailed you.
Oh, you emailed me? That's okay. Thank you. Okay, I've tried adding you now. Cool. So once you're in that project, if everyone sees AVDF here, which is the project name, you can just go to the search and just search for BigQuery and click on that. Once everyone clicks on that, there should be a pane on the left that shows the actual project. Don't worry about the name between AVDF and that. One is the actual name, one is the project ID. That's a numerical number that GCP stores. So can everyone see at least this piece here in the BigQuery console?
It's called what?
It's the Fleet Petal 295300. Oh, I can zoom it in. Is this better? Okay. Sorry. Sure.
What's that?
All right. So just a moment. I just want to make sure. Okay, sounds good. So when you go to that console, I created a data set there called Hawaii Marketing Event Lab Ankit. So there are 3 dots to the right here just by the project that say create data set. If you guys can create a data set with your name there, that would make it very easy for you to work under that. Otherwise, if you want, you can work in my data set as well, that's fine. But it's easy to sort of look at your models and everything in your data set, so you can just do create data set. And you can give an ID that's just, suppose, your name, any name here, and just do create data set down. So that will create a container for you to work in, or your workspace there. That will ease out things a lot. I'll wait for everyone to be done, and then probably we'll get started. Has everyone been able to create a data set in their names? Just
Ask the negative question. Who was not able?
sorry?
You should ask the negative question. Who was not able to?
Sure. Yeah. Who was not able to create a data set? Okay. I assume that means everyone is. Thanks for that.
Yeah, it's easier.
All right. So the first model that we are going to talk about is logistic regression. Like theory-wise, if I have to simplify it, it helps you determine the probability of an event as a yes or a no. So it's binary basically. It tells you whether something is something that you want to predict. So for example, in the context of this conversation today, we are going to predict whether a given buyer is going to come back and buy something or not. So basically a probability. So when we say we are going to determine that probability, it can either be a yes or a no, or in binary terms it can either be a 1 or a 0. So when we think about those kind of use cases, then we probably talk about logistic regression. And an important piece here is you sort of know what you want the probability for. So for example, you want to know, in this case you want to determine the propensity of someone coming back. So you know what you want basically. Or I think there is another interesting application of these kind of models where people talk about some transaction being fraudulent or not. Again, in this case, you know that you want to understand whether something is fraudulent or not. So these kind of learnings are supervised, and it's just a term, but it just means that you know what your end goal has to be, which is either predicting someone's coming back or predicting a transaction to be fraudulent and stuff like that. So logistic regression is that kind of a model, and the salient feature of this model is It basically buckets your data into a yes or a no for a particular thing that you want to predict. So that's the first model that we are going to create. We are going to create two versions of this model, one not so great and one a little bit better than that, so that we can also talk about how to improve these models. I mean, that's another PhD subject, I would say, so we won't go too deep into it, but we'll see how easy it is to write SQL and sort of improve a version of a model. An improvement comes with respect to key metrics, like we would improve something that we can measure. So we use these metrics to measure the performance of the model. We'll go a little bit into these measures. And then the second model that we are going to create today is clustering. So I think when I speak with a lot of marketing execs and people who are involved deeply into marketing, there is a lot of campaigning going on, like, hey, I want to start a campaign for X number of users or customers. My wife also works for an online retailer, and their job is whole and soul to determine what are the best campaigns for a particular set of customers and how we measure or track how successful those campaigns have been. So a precursor to creating those campaigns is to understand who you should create those campaigns for, and maybe who you should not create them for, and who you should create other campaigns for. So here you just know that you want to create clusters, but how are those clusters created? What are those clusters created on? All those things basically are a little abstracted. So these kind of models are unsupervised because you're not training them on the fact that, oh, I need a probability of a yes or a no on this. You just say, this is my data, just cluster it into multiple clusters and stuff. So this is I specifically chose this model, this type of model, so that we get a flavor of both the models, where in the first kind of model, you definitely know you want to see whether someone will come back or not. And in the second model, you just throw data onto the model and it just clusters it for you, and then you see, oh, there are 5 clusters that are created, and each cluster has some features to it that I can understand from the business side of things and make my decisions. So these are the two flavors, and then we will also understand, again, for this model as well, what are some metrics to know to help you identify whether your model is really good or you need some improvement and stuff like that. So this is going to be the overall technical agenda, and these are the two models that we are going to create. This might be too simple for someone who has been doing this day in, day out, so please forgive me for that. And this might be interesting for folks who are seeing it for the first time, or if it gets boring, please let me know. I'll try to add some more anecdotes to these. And if you have any experiences with these, if you want to share them before we get started, please feel free to. Has anyone heard of these two kind of models before? Okay, cool. All right, so let's get our hands dirty now. Let's start with the first one, which is the logistic regression. That is the Git repo marketing logistic regression. Please let me know if everyone is able to access that. So basically we need that, and we are going to toggle that with your data set that you created, or you can use my data set as I mentioned. So let's copy this query and see what it shows us. First, I'll have to zoom out a little bit so that I can myself see.
Show feature?
Yes, that's correct. So we'll go step by step. The first folder is show features. So if we just copy that in BigQuery console and just hit the run button, we just see bounces, time on site, and will buy on the next return visit. There are 3 things that we probably see here.
Wait, I'm already so sorry. What
Yeah.
you do to open the editor and
Yeah, sure. Sorry. So, yeah. if you, let me close this and show it again. So basically, when you are here,
Table. Okay.
yeah, you can just do create table or no, not create table. Sorry. Where did it go? I just had it. Oh yeah, you just need to click on the button. So basically, when you open that data set here, there is a plus button on the right which says new query. So that's the console that you need to go in. Yeah, let me know if everyone is in that console and they are able to copy this query there.
So where are the data?
Yep. So the data is in a public data set, data to insights, which is this data set, which contains the web analytics data. And as one of the pre-reads, I also sent the schema of that data, but maybe let me show that to you quickly so that we get a sense of how that data looks like. So this data is almost a copy of Google Analytics data, but it has all the actual visitor IDs and everything masked for the purpose of honoring security and stuff. So visit ID, dates, everything here. So this is how actually the GA data captures all the web activity when someone is on their website, and all this activity is being tracked, where what is the number of hits, what was their channel, did they come as paid search, direct search, etc., etc. So all this data is the source data basically. So if I have to summarize how this source data looks like, it actually tracks the session that a user is in, tracks their behavior in that regard, and then loads that data into GA. And from GA, there is a pipe that we can use to put this data into BigQuery. So there are connections that Google Analytics has to port this data into BigQuery. Usually people do it once a day, or if someone wants real time data, they can stream ingest into BigQuery. We can talk about that after the session on that whole ETL piece of it, or ELT piece, but for now this is how the source data looks like, and we are going to use this data to sort of say that, okay, I want to figure out how the bounce rate and the time on site is impacting whether someone will come back or not. So basically that's the use case. And your business can have completely different use cases. Maybe someone says, I don't care too much about the bounce rate. I care about other features like geography, or I want to understand if geography is a feature in someone coming back to my website or not. Maybe the products on a website are more suited to a particular demographic and a particular state or a particular culture and stuff like that, and maybe there is nothing to do with the bounce rate. But this is just for exemplification. I just took bounce rate and the time on site, and we'll see how and if these are really impactful to whether someone will come back or not. So if you run this simple query, you will sort of get these three things, which is the bounce rate, the time on site, and will buy on the return visit. Now this third feature is the one, I'm calling it a feature, but I mean, this is actually something that we are going to predict on some data. We are going to give that data the bounce rate, the time on site, and that will tell us whether they will come and buy on their next visit or no, whether it will be a 0 or a 1. So that's going to be the use case. And business wise, I think that use case can become important because it can tell you if someone is going to come and buy back, and you know that with this data, then you can tailor your marketing strategies towards those customers. And if this data is showing you that someone is not going to come back with really high probability, then I mean, with all due respect, you can tailor your marketing efforts to do something for those kind of customers that can improve their propensity to come back. So that's the kind of intelligence that these exercises are able to provide to you, where now you know, okay, I know for 90% confidence that this person is going to be a repeat buyer, so maybe let me preemptively give them some offers and stuff like that. Or I know that this person is showing me will buy on return visit equals 0, so I don't think they're going to come back. Maybe something was off on the website, or they didn't like something and stuff like that. Maybe let me give them some other kind of offers with some 50% off or something as a discount. So that's the kind of decision making it gives you on a high level, but that's why we create these models. So basically, to reiterate, we are going to use the bounce rate and the total time spent on the site to figure out whether someone will come back or not. Any questions on this before we move forward? All right. So now let's do the fun part. Let's actually create the model. Usually when we create these models outside of BigQuery, the folder is second, which is create model, and you can just copy the code and put it in BigQuery. Uh-oh.
Not found data set.
Yeah, sorry, I think there is a reason for that. Which is, we should put the data set that we created in create or replace model. So just give me a sec. Maybe perfect. Yeah. So in the first statement where we have create or replace model, there you might have been seeing DS1 or something like that, because that was the first model that we had created in that data set and stuff like that. So if you can replace that DS1 with the actual name of your data set, that should figure out the problem. So I'll zoom it and show you exactly what I did. So here in the create or replace model, just put your data set name there. That's all. Like my data set name was Hawaii Marketing Event Lab Ankit. You can use this as well if you want. Or you can, it would be better if you just put in your data set name there. And once you do that, that error should go away, ideally.
Wait, okay.
It's the first line,
Yeah.
create or replace model, and there it needs your data set.
I got another error. It said data set IDs must be alphanumeric.
Oh, okay. So let me come back to you and help you create a data set. Let me check if I see some models there. Nice. I'm starting to see some actual models. Nice. So I think all of you who have created the model should be able to see what your model was. Sorry, I'm piggy banking on one model, Chris D's model. So if you go to your own model in your own data set or wheresoever you created it, you should actually see the name of the model that you created it, and on the right you will actually see the model that was created. So can everyone see this piece? I'll come over and show it to you guys. But just know what model name you created so that it's easy for us to figure out. Let's see. Are you able to see your model?
Yep.
Awesome. Yep. Amazing. Yep. That's your model. Congrats. Yeah. Awesome. Are you able to see your model?
I think so.
Yeah, nice. Are you able to see your model? Oh, it's still creating. Okay, awesome. How's it going? Yeah, that's perfect. Yep. Was I using yours? Is it? Okay.
No, but
Oh, cool. So this is the first step, right? We used a simple SQL query to create a model. And, sorry, yes.
Can you explain the model a little bit more?
Yeah.
After,
Yep, sure. So let's actually look at the model a little bit more. Where is the model? So basically what we are trying to do in this query is we are giving the model primarily three things. One is for a given visitor ID, which is the full visitor ID, and this is non-PII data. This is completely hashed out data, so you don't have to worry about that security piece and stuff. So what we are telling it is, hey model, I am giving you a visitor ID, the bounce rate of that visitor ID, and the time on site of that visitor ID, and whether they came for a new visit or not. So what this model is giving us is, what we are feeding to the model is, we are telling it, I, Ankit, as a visitor, had a bounce rate of something, and my total time on the website was some 3000 seconds or something like that, and I did come for new visits. So I'm giving that data to the model, and then I am telling it, okay, now you know the data for around 9 months of customers, you know their bounce rates, you know their time on sites, and you know whether they came for a new visit or not. Now can you predict for a new set of customers, if I give you their bounce rate and their time on site, whether they will come back or not? So that's what this query is doing. So this query is actually giving the model a training on 9 months worth of data. You can always toggle with it and give it 12 months or 13 months or 8 months or 6 months based on what kind of data you have. But what we are doing is we are training the model to think in a certain way, and that certain way here means is, hey, I am giving you the bounces, I am giving you the time on site for visitor this, and this visitor based on this bounce and time on site came back as a next session, which comes from the total.new visits in the source table that we had. And now you tell me if there is another visitor, a future visitor, who has a bounce rate and the time on site this much, based on the knowledge that you have acquired on these 9 months, do you think that visitor will come back to us? So that's what this model is doing. And why we have trained it on 9 months of data was because now we are going to do something interesting where we are going to test it on 3 months of data, where this model doesn't know exactly whether there will be, this model will predict based on these two, bounce rate and time on site, whether someone came or not, and then we will test it that whether that's actually true or not. So basically what we are going to do is, now the model is trained, all of you have trained your model or created your model. Now what we are going to do is we are going to test that model. So testing that model means we already have the data which will actually tell us whether that person came back or not. We will ask the model to predict that and compare those two things and see how accurate the model is. So that's what this whole process is doing. I know I spoke a lot on this, so I'll pause a little bit to see if anyone else also has any questions on exactly what this model is trying to do. Yeah, go ahead.
Maybe this is jumping ahead, but would it be better to train on sort of a random sample of the entire data in case seasonality factors in?
Yes,
Okay.
totally, yeah. Training it on the data that we think the model will get skewed on is always a difficulty. That is a I wouldn't say it's a problem, but it's a question that data scientists think through every day. And that's where the functional knowledge of the data comes a lot handier, where your marketing knowledge can also come a lot handier on, hey, I know that I shouldn't be training my models only on COVID data, for example. Because that data, if for some reason, unfortunate reason, your sales went down, the model will think that, oh, the sales were always down. So that's where the ML ops piece comes into picture, where the data scientist has to work hand in hand with marketing professionals to know when to retrain this model, basically. And all that cool stuff comes into picture there. Like Lance and I had one other customer who was seeing a degraded model performance. By degraded model performance, I mean their actual data was saying something and their predictions data was saying something, and it was a time series model. And when we went back to see what that model was trained on, it was trained on COVID data. So all the predictions that that model was doing for the future were on a very skewed subset of a year's worth of COVID data, where it was all anomaly for that. The sales that they were experiencing in COVID was not their usual sales. So that's where, to his point, this is just an example. In a real world, we should know what data is a good training set, which is balanced, which doesn't have just one output for everything, basically. So those are the things that become very data science-y and data analytics wise. They are important to consider. But your point is absolutely valid. Like, it's always good to train the model on distributed data. So maybe for someone who doesn't do this often, I can just ask a simple question. Why would you want to train a model that's on distributed data or random data, as he mentioned? What would be the advantage of it? Can anyone just think through that? And I can give a hint if needed. Like, training a model is like, I think in my definition, it's like training a human being, but training something at scale. So if I am training a human being to see a certain kind of data only or patterns only, what would happen if I then ask them to predict something that's completely out of the blue? What could be some results of it? Yeah, go ahead.
Basically just overfit it to one scenario.
Yeah, exactly.
Or a subset of scenarios.
Exactly, yeah. If I'm always trained to drive a gearless car, then if I'm then put in a situation where I'm told to drive a car with 4 gears, I'll sort of be overfitted to just driving certain set of cars, and I wouldn't be able to drive another set of cars. If I'm trained like for one day to drive a cool Maserati or something like that that has no gears and stuff like that, and the other day I have to drive a car that has 4 gears and stuff like that, I wouldn't be overfitted or over comfortable in one set of cars. I'll be able to drive multiple. And then if someone tells me, hey, can you drive a U-Haul which has this gear and stuff like that? Not completely equivalent to how my Ford had the gears when I was getting trained, but I'll still be able to better do well in that scenario. So that's exactly the reason that training a model on a particular set of repetitive data might do more harm than good. You might feel, wow, the model is predicting everything. But the moment it gets put off on a data that it was never trained on, or the type of data that it was never trained on, then the model will get low marks from you guys. So that's the reason, and that's a very valid point. Thanks for bringing it up again, that it's important to know what data to train it on and what data not to. And this piece does not need as much of data science or core master's degrees or STEM degrees and all. It is more of you working with your business and understanding your data left and right. So it has a lot of functional aspect to it than technical aspect, in my experience. If you have something different, please feel free to share. But that's what I have felt, that working with the business teams, marketing teams to figure out what are the data patterns is one of the inputs to the data scientist taking decision on what data to train it on. So that's how at least most of the projects at Google work. But yeah, if anyone else also has any experiences or questions, please feel free to ask.
I do have a question on the
Yes.
SQL structure.
Yeah.
Because I'm more the Python guy, not necessarily using SQL for machine learning. So
Yeah.
just tell knows what is y, the dependent variable? Is it line 5 because there's a label? Or is it
Yeah.
because we do a join?
No, you're absolutely right.
Okay.
Here, line 5 determines what's the exact label.
Okay. So that is the line that tells
Yes.
the code that that's going to be the future to.
Exactly. And that's another great point. Since we were talking about this model and I was talking about supervised learning, you have to tell this model what you need the predictability on. So here we needed the predictability on whether a person will come back or buy on the next visit. So you need to tell the model that, hey, at the end of the day, I will take your test on whether a person is going to buy or not. So the model will train itself on that feature. Like I have to just learn when a person buys based on bounce rates and times on visits, when does it buy, when does it buy, when does it buy. So in case of logistic regression, you have to tell the model explicitly that I want predictability on this label basically. So this is one of the key differences between this model and the next model that we will go through, where this concept doesn't exist. There is no label. It's just clustering the models. But in this model, you have to tell it like, I want the model to be trained on this. It's just like saying in a class, at least in my class when I was in India, I was trained on different subjects like English, math, science, and stuff like that. So when my math teacher was training me, the expectation was that they would give me a test on math, basically. So I knew that when I'm getting trained on math, I'll have to appear for a math test. So I was very supervised there, that it was a structured model where I knew what I'm going to be tested on. Now, let's assume an exercise where teachers are like, okay, let's actually group students with similar interests. Like, I like music, I like wildlife, and I like coding. And there may be people or students like me in the school who do that. And then there may be some other students who like sports maybe more, or whitewater rafting or anything else. In that case, I can't tell them like, hey, I'm going to train you on this and then you predict this. I'm just grouping people. So that's where label will not come into picture. But for this model, yes, the label is going to come into picture. And you have to explicitly mention the column name that will be your label. So to Francois' question, this is one of the mandatory syntactical things here for this logistic regression models. Any other questions on the create model statement?
I have a lot more questions, but maybe, how does he know that full visitor ID is not a feature?
Because we say select star except full visitor ID
Where?
here. Yeah, no worries. No worries. So the good part about this model here is that if someone knows SQL, which is this part from select part to the group by part or using part and stuff like that, using is just for the join here, they just need to understand what model they want and what labels they want for a supervised model, and the model gets created. Do you want to share some experience on how you do this in Python or something like that? I think the syntax should be very similar, but how does it work?
Well, so line 9 down is preparing the data set.
Yep.
So that can take, one line or 10,000 lines depending on where your data are, whether you have to clean or whatever. But
yeah.
Otherwise, it's just one liner. Usually in Python there is a package to do that.
Sure.
And I will guess, so all options will go in line 3 to 5.
Yep.
There's a lot of free parameters to
Yep.
set up. That's where they will go.
Yes. All the, for in your language, all the hyperparameters, all the parameters and all go here, and then the data preparation happens here. We started this feature very late, basically. This feature came in a few years back in BigQuery, and the reason for this was that the business analysts and the data analysts at Walmart, basically, that was the customer that inspired us to basically do this, like Home Depot, Walmart, and all those folks. They were like, we have a constant back and forth between the data analysts and the data scientists. Data analysts have to prepare the data somewhere, and then the data scientists have to write a pipeline to get that data somewhere, train it, and then by that time the training data is always changed in the data set and stuff like that. So what we thought was, if we can train the model locally where it physically is present, that's going to be a big win for us. Like here, at this point in time now, if any of this data changes at the backend, for example, and BigQuery, it changes it, you just need to run this train statement again, and the model will train on the latest data. You don't need to physically move it somewhere else, saying that, oh, I'm the data analyst, sorry, the data changed. Hey, data scientist, the data is updated now. Your model is stale. Can you please fetch the whole terabyte and petabyte of data somewhere else and train it again? That kind of bottleneck is solved through this problem. Syntactically, it might be very similar with Python, but we wanted to address that data locality concern with BigQuery ML. So that's the main reason behind this. Let's talk through. Sorry, does anyone else have any questions on the syntax or anything else with regards to the logistic regression model? All right. So evaluating model. So basically, there is a console there which is evaluation. I think almost everyone was seeing that when I was there to check your model. So this piece is like, I think, the most abstract and I would say complex piece to understand. I, as a data engineer, have been trying to wrap my head around all these metrics and stuff like that. But what I know is that the ROC curve here and all these curves here, they help you understand how good or bad your model is. And there are these terms here. So for example, let's see recall. Recall is a term that tells you a fraction of actual positives that were predictive positives. So I think recall is when you predict something to be positive and it is not, I guess. So that's what recall is. So your recall should be low for your model to be good, basically, ideally. So that's what this means. And all these terms have very different, I would say, meanings and importances in different industries. Fraud might want very less recall, and then sending emails to the right set of people might need very high accuracy and stuff like that. So if we want to talk about these terms and how we tune these in BigQuery, I personally think that would be a separate session, or we'll talk about them after this session so that I understand your requirements a little better. But I just wanted to show you that there are ways here where you can simply evaluate your model either through the console, or we are going to also evaluate it using the SQL query so that you know both the worlds of things. So let's go back to the actual evaluate model folder, and when you copy this query here, please, I'll just have one small request. When you copy the query, the model name there should be exactly the model that you created. Otherwise, it will show you the same error that that model doesn't exist in the location and stuff like that. So maybe wherever your create model statement was, just copy paste your model from there and put it in line number 10. Here, this line. This should be your actual model name. This is the dataset name, the DS1. So your dataset in which you created the model, and this is the actual model name. Let's see. Sorry?
decent result.
You got a what? Sorry.
I run the evaluation and it said decent, so I'm happy.
Let me.
Based on the case one, yeah, the decent result, yeah.
Oh, you got a decent result. Okay. Yeah. Let's see why that was. What am I doing?
Is your model called Taylor 1 or is it if you expand out?
Oh, sorry. Yeah. Yes, that's correct. I'm just using some. John, is it okay if I use your model too?
Sure.
Sorry.
I'm not following app, so.
Oh, I'll come to you and. It should run. Okay. So for this model, it shows that my ROC is some 72%. So there are some metrics on that means it will be this accurate and stuff like that. So I just abstracted it saying that if my ROC is over a 0.9, then it's a good model. If it's 0.8 or greater than that, it's fair. If it's 0.7, it's decent. If it's less than 0.6, it's not great and stuff like that. So I'll discuss with you what ROC means and stuff like that when we are chit-chatting. But for now, just assume that these are the measures or the terms that actually help you understand whether your model was good or bad. Like, because most of the times we get questions like, oh, I now created this model in BigQuery ML and it's working so well and it's so simple to create and all. But how do I know whether it's going to do the things for me in an accurate manner or not? So to calculate the efficiency of the model, this is just one example. I just wanted to showcase to you that there are levers for you to pull here and determine whether something that you created is good or it can be improved and stuff like that. So this is one way to look at your model and figure out whether it's a decent model or a fair model or a good model. And now in the next set of exercise, we'll go over how we can improve it from decent to fair or to good using some data engineering, because there's always a room for improvement in these models. So we are going to go over that too. But I'll probably come to each of you and see if you can see how your model fared. It would all be the same decent because we ran the model on the same training data set and everyone ran the exact same query. But I still want to come and see if this query is running for you guys. So I'll just probably swing by. It's running? Okay. Hey, how are you doing? Okay, awesome. Hey.
So, this is the
Yes.
third one, and I think I pulled the model from here, but I don't think I put it in the right place. So I'm getting a syntax error.
Can you delete that last,
That
that
one.
thing, yeah, and then put a comma there. 1 minute, let me.
Yeah.
Sorry, I'll be back. I'll just
Okay,
bring mine. Yeah,
That's fine.
because I used yours, so I'm just gonna. So this is evaluate Website model. Yeah, I'll just do Hawaii Marketing Event Lab.
So take this out.
Take this out because we know you're in that project. And then John Tepper, comma, and then there should be another open curly bracket. Yeah, open,
way?
yeah, other way. Yeah. And then you can do, yeah, this should really work. Illegal. Can you go down, please, once? Down. Yeah. Can you remove that git thing? Yeah.
The whole line?
The
or just-
whole 3 lines. Yeah. 33, 34, 35. Just 33, 4 and 35 now. This should work. Okay, perfect.
Okay.
So,
Do I need to run it?
yeah, you can run it. All right. So, now for some reason we know that the model is decent and stuff like that, but we want to see if there is anything that we can do to this model and basically improve the ROC scores and stuff like that, or stuff like that. So what was this, if I have to go back first, like to identify some of the things that would have affected the performance of the model, what were the 2 labels features that we used to predict? Like one was bounce rate and then one was time on the website. Those were the features that we trained the model on, or basically I would say that was the syllabus that was given to the model to study. Those were the books that the model read, and then it came to the test and it got some 72% if I have to convert it into an education exercise. If we want to improve that score, we'll have to see what are some of the things we can improve. Either those features weren't great, basically. Either those features like bounce rate and the time on the website weren't the right features for us to predict whether someone would come back or not. Or they were okay, but we might need more features to enhance the model and say, okay, these are okay features, but if you can check something like where the visitor came from, basically, or if you can check like whether the visitor were using the device, a mobile app to do the buy-in, or whether they were using their tablet, because the UI experience of different things can change. Server can go down, tablet performance might not be great, so just session went down and stuff like that. And also basically there can be other things as well, like whether they actually came from searching things organically, or they came from a referral from someone, or they came from someone else. So there are a lot of such features that can actually help this model to be either improved or go down. So we'll have to do that and see, basically. And we can also see how far the visitor got in their first checkout process. Did they actually buy things in the first visit or not, and stuff like that. So adding those kind of features, now we'll create an enhanced version of the same model with the same label, whether the person will come back and stuff like that. But we are going to give it more syllabus to study or more features to learn from, and then we'll check how the performance behavior, how the model behavior changes. So the basic premise of what we discussed here was that I think this field of study is called feature engineering, if I'm not wrong. That's how it's termed, like nomenclature wise. So you are engineering features to improve the performance of your model, or to understand which feature impacts the model the most, basically. There is weighting as well, like maybe the geography doesn't impact the model as much as the channel from which someone came, which is a referral or an organic search and stuff like that. So this is a full science. I haven't fathomed it. I don't think I will in this life, but yes. So there are ways to at least experiment, and easy experimentation using BigQuery ML, where you can just add a feature to the SQL query or remove it from there and then recreate the model to check how the ROC curve is looking like and stuff like that. So it's a very simple exercise, but it can become very important for production grade models which you want to be very performant and stuff like that. So let's start that. Let's go to, sorry, I'm not sharing, I believe. Folder 4, which is feature engineering. So this query doesn't need any dataset changes and stuff like that, so you can run it vanilla on your console. Some 120 MB data that it will scan and stuff like that, and it will give us like all these additional features that can now be fed into the model to actually tell us whether someone will come back and buy something on their return or not. So basically, again, we will train the model to predict this piece, and then we will ask the model to predict it for the future data. So here, if you see, we have source, like where did the customer or someone come from, what was the medium of this search, was it organic or not, what's the device category, did they visit the website using their desktop and stuff like that, and what country they visited from. Now, as easy as it seems, like capturing this data in the first place is also not very easy. If someone is using a VPN or something like that, I would never know whether they were sitting in US and searching, or they were somewhere in like Greenland or Iceland, searching something there. But the concept would still remain the same, and in all good faith, the assumption is that people are not using those VPNs and masking their web identity as much as they should, I believe, and giving us all this data of what was the channel they came from, which country they were surfing from, what was the device category, and all this cookie data and everything that the web servers keep capturing. So GA captures this data, and we copied over this data into BigQuery for our model analysis. Just an additional background that has no bearing to this session, but I still wanted to talk about that. So now we are going to give the model more syllabus to learn from, more variables to learn from, and now what the model is going to do is it will be like, okay, how does the source being Google or the medium being organic change whether the customer came and will buy on the return visit or not, in addition to the features that we had, which is bounces and time on site. In all honesty, you can remove these features as well and just see if these features can create an impact on this piece or not. But for now, I'll just keep them so that I know iteratively has my model improved or not. So now the model will also try to see if someone being in United States, Indonesia, or India had any bearing on whether they came back for the visit. And that might be interesting if something of that sort happens, because that means that then your products or the website is a little more aligned to a particular set of users in a particular set of country than being a global one. So those are the things that we are going to learn, but this query just shows you the additional features that we are going to input into the model. And now again, coming back to the cool part, we are going to create the second model with additional features that we just spoke about, which is not only the time on site and the page view and the bounces and all, page views, source, medium, channel grouping, device category, etc. So if you don't mind, if you can go back to this folder 5, copy paste this SQL query, put it in your console, and again the same exercise, put it in your data set and write a name that you can later identify to evaluate it. So I'm just going to use the same Hawaii Marketing Event Lab Ankit as the data set, and I'll put this model as Ankit 2 so that no one is confused. And if you see this, like, it also tells you that this query will process 120 MBs of data well in advance. You know how much data you're going to process for this query. And this is the ease of use that BigQuery gives us. Like, I didn't have to do a bachelor's to understand that this query is going to process 120 MBs of data. It just shows me because I have the table there, which is the data to insights e-commerce web analytics. BigQuery has the metadata for that table at the backend to see how much data it has, and it has all the means and levers to see how much each of these columns in size mean to, and it does all this like on the fly to tell you that this model will approximately process that much of data. Empirically, we haven't seen a lot of discrepancy between that number and the actual data that's being scanned. So it's more or less very accurate. And how it helps people is, it helps you even optimize cost, right? Like a model is just a model at the end of the day. It's just something that you train it on. Doesn't mean that now if you don't need, you are training it on petabytes of data and then ramping up your BigQuery bills. So this is like a soft governance check on the right side, which tells you, hey, this is the amount of data, and if you go to the BigQuery pricing, you'll know this costs some cents or something to train this model right now. So it just gives you that mental framework on, this is my model training cost, which is a few cents with respect to this model, and this is what I'm investing. So it's pretty cost effective from that front as well, but it gives you that lever. So if you run this now, we should see model 2.0, which is supposedly the improved version, because we've added some features to it that we think might improve it. So let's see. And again, I'll swing by to see if anyone is having any issues. Let's start from the side. Hey, all good?
Yeah. Oh, no, there it is. I was just wondering. It showed up. So
Perfect.
I was wondering when it was going to show
Yes.
up. Okay.
Sure, yeah. Hey, still running? Okay. How's it going?
Good. I think it's done.
Okay, awesome.
Were we supposed to see anything?
We are going to see the ROC curve again on this one. So we are going to come back to that piece. Hey,
I'm still running.
awesome. Cool. How's it going? Is it running well?
Yes.
Cool. Sure.
Scatter, pinged and said he was, he saw it.
Sorry, I couldn't see it on the screen, but I'll ping him back.
Yeah.
Yeah, sorry about that.
No,
Yeah. Hey, how's it going? Oh, it already ran? Amazing. Yeah. Come to the evaluation. Did it run? Cool. Hey, sorry, I couldn't come to you
It's okay.
before, but
Okay.
is everything running
Yeah,
okay?
I'm
Awesome.
I'm just starting to build it still.
Okay. What step are you on, if you don't
The
mind?
very beginning.
The very beginning one?
Yeah. So
Okay.
I just make my own,
Yeah.
and then
Okay.
I just have to make this.
Yeah, I'll come to you. Like,
Yeah.
let me know. Yeah, we'll have a break as well, so I'll probably
Okay,
come over
thanks.
here. Cool. So we'll just give it one more minute for everyone's model to be running, because everyone's running in the same project. BigQuery is trying to optimize the resource utilization at the back end, so you might see a little bit of a wait time there, which is fine. And after that, we are gonna evaluate. Yep.
The after finish running, it say create another model. Is that right? So they create model 2.
Yeah. So we are creating two different models. So I think you already created this model for you.
Yeah, I click this and this new one.
Yeah.
Okay.
That's all. You don't need to recreate another one now. You already have two models, which is great. So for all of you who have already created the second model, if you go to the 6th folder, which is evaluate this model, let's see if this model has a better ROC score or not. Again, the only thing here that might change for you is the name of the model that you created and the data set you created it within. So I'm exactly going to copy paste the name of my model that I just had. And for the evaluate, it will again be line number 10. So I see that this model has a better ROC, so it might perform well for us. So a little bit of feature engineering, functional conversation on what factors can influence whether a model is performing well or not can help you improve the model. So it's not as much of a science, it's more of an art and experimentation, but just want to focus on how easy it is. Like you can just remove some features from the query and retrain the model and then run the same query again and check how well the model is performing and stuff like that. So doing all this with SQL is very simple, and the best piece is the data physically resides in BigQuery, so you don't have to spend a lot of time in data engineering, piping the data somewhere else where the data is, and then training it and stuff like that. So that's one important piece here. Now, since we got to know with the ROC score and stuff like that that model 2 is a little better than model 1, let's use that model 2 to predict, do the actual prediction based on all the labels that we had to see whether a customer will come back or not. So let's do that prediction now. This is the actual use of the model. This is the test of the model basically. This is what we built this model for, and this is what this model is going to do. It's going to take all the input features, which is the geography, the channel, the page views, the bounce rates, and everything that we have been talking about, and it will tell us, hey, based on the data that I have, visitor ID A, B, C, D, E is going to come back, or it's not they are not going to come back. And once you get that kind of data, then you can empower your marketing teams to say, okay, these are my top 10 customers or top 20 customers who I for sure know are going to come back to me. I need special features, I need special offers for these, or I need a proper campaign for these guys. These are the customers who I don't know whether they'll come back or they'll not come back. I need special features for them. So the whole analysis now changes into driving it into business outcomes. So here, again, the only change that you will have to do is in line 4 with your actual model, and you can just run this query with your model name. And if you see here, the model has started predicting, like, will the person come back and buy on the return visit or not, and with the probabilities. Like, I think 56% they will come back and 43% they will not come back. So it took the higher probability and gave it that label. So now you're able to see that, and this record also contains the visitor, I assume, or it contains some session. Yeah, okay. It has a session, which is good. So you can use this session to identify the visitor and stuff like that. I think deliberately, or I do have a visitor as well. Okay, yeah. So this unique session ID is a concatenation of the visitor ID and the session ID. So you could have just had the visitor ID here as well, but this is doing it at the session level. It can tell you that these were my session parameters, and I can tell you with this much probability that this customer is going to come back and stuff like that for such kind of sessions. So this is what the model is doing, and we use the second model for this because that had a better evaluation criteria. So that's how this model is operating, and you can start using these models to take some decisions and stuff like that. So this was the test of the model basically that we just performed. So this was the final for that model. I do have someone really special to talk on this call about their experience with these models and stuff like that, if you guys are open to that. But we can take a 10-minute break, 5-minute break, if that's okay with everyone. And then,
Maybe getting them online.
yes, I'm going to get them online, and we're going to have them talk about their experience with these models as well and how they improve these models and stuff like that, so that people who are really curious, they can get to learn it from them as well. I learn from them a lot. They're on my team, so it would be good to have them talk for a few minutes. But yeah, so this was it. I hope this was simple, if not helpful, or helpful and simple both, or if it's neither, then we'll talk about it after this session and I'll get some feedback from you so that I can myself improve on such sessions. But this is what it is. Like, someone who knows SQL can probably do this. Like, we did it in an hour or something. So, and that too because I was talking a lot. So if we have those queries and if we know what labels to train it on, or even if we don't know that, we know what queries to write, we can probably turn it around in a very little time. I mean, and again, honestly, this is a starting step, right? Like, modern data pipelines are much more complex. There is not just one table. There are millions of tables that need to be joined and data sets aggregated. So there is the whole data engineering piece that goes into it. But if you abstract that and if you have your data prepared that you would need to do anyway, if you use BQML or if you don't, then after that, the step to create these models and experiment with them becomes relatively simplified. So that was the main intent, to show these and try to see if some of these align with the marketing stuff that you do. We'll have some questions now. If someone has any questions, we'll go for a break for 5-10 minutes, and then we'll have Skander, who's going to talk about his real life experiences on these models and how he splits hair on improving them and stuff like that.
I have a quick question. Where do you change the threshold for the score?
Yeah.
Decide whether it's going to be a 1 or 0 icon?
Yep. So the create model has the ability to change the threshold there itself. I didn't change it. It took the default threshold, 0.5.
Oh, the default is right now 0.5?
Yeah. Yeah.
But there is an option somewhere.
Yeah, there is an option in the evaluate. It can tell you that if you would have changed it to this, it would have given you that much accuracy, recall, and stuff like that. Yeah. Yeah.
Talk through like a real world application of this. So it looks like if I read the code right, and this gentleman asked a question of what time frame you're training it on, right? It was the previous time frame, say like a year ago.
Yeah.
I would run it on, say, last month's data.
Yeah.
To get that subset.
Yeah.
And their propensity to buy, right?
Yeah.
And then you can also though run it live on a daily basis if
Yeah.
you wanted to.
Yeah.
Gotcha.
Yeah. So if you run it on last month's data and you, for your business aptitude and the experience that you've had, know that that data was good for someone to be trained on, and then it will be helpful to predict the sales outcomes for this, because there is no random catastrophe that's going to happen that's going to destroy all the sales and marketing and stuff like that. That's fine. If you do daily training, then you're actually doing a lot of training on the model and then doing predictions. So basically you are telling the model, hey, forget everything I told you till yesterday. Take today's data and use only today's data to train for tomorrow or tonight or stuff like that. Again, thinking of that as a child who's getting trained on something, you're giving the child new books every day to study and then ask them to take tests every night and stuff like that. That is okay if they have enough to study and if they have enough content to pass the test, but that becomes an issue when the model starts thinking that I don't have enough data to predict outcomes. Like I haven't seen these enough scenarios to know whether I can tell whether the person will come buy back or not. I'll give you an example. So for example, if you trained your model on months worth of data, you had some million rows in which you had different scenarios where you knew some people from US buy something and some people don't. The model knows that there are scenarios where I can attribute someone being in US to whether they will come back or not, because you had months worth of data. If you do the same thing on a day's worth of data and you got only 2 records for US buyouts, if you now ask the model at night to predict, hey, this person is from US, will they buy or not? The model will be like, I just had 2 entries, they both bought, so I think this one will also buy or something. So that's where the model becomes less and less intelligent, because I hate to say this, but its quality is a direct function of the data it's fed, because that's the only source of truth that it has, and it doesn't have this extra worldly intelligence, cognitive, and experience from a human interpretation, subtleties of all that stuff to see, oh, okay, actually, you know what, those people from US bought because someone referred them and someone's aunt or the uncle called them and told them to buy this because it was a really good product and all. Since the model doesn't have those nuances, it needs a good set of data to be trained on to be better with respect to predictability. So that's how we decide. We usually give it a big data set to train on, and then we do live predictions every day or every and that's how Amazon does it too. Like, I think it takes months and months worth of my session data when I go to the Amazon app, and then it gives me real life predictions when I'm on the app saying, this is your feed, this is what you can buy, and then it also does recommendations like users like you also bought this product and stuff like that. That prediction is happening while that session is there, but the data it's training is months and months worth of my activity data. So that's how it basically in real world it happens. And maybe we should ask Skander to shed some light on that too, because he's done a lot of this retail time series stuff.
If recency is important, can you use a rolling time period to like train on, so that way you're still getting the sufficient range of data, especially
Sure.
like there's seasonality or purchase frequency is long, but then you're getting recency of this, like say rolling 12 months or rolling 12
Yeah.
months.
Yeah, totally. Yeah, rolling is fine, and I think we usually want to train the model as frequently as it makes sense, because recency also becomes an issue. Like, to his point, a month's worth of data might be a good chunk for me from a size perspective, but that might become stale. So there has to be a balance between how recent the data should be and how much the data should be. So it has to be a balance. And honestly, I don't know if there is a formula to predict that. It's just trial and error, and you keep doing this and figuring out how recent the data I need and how much the volume of the data I need. So that's the balance between both those things. Hey, Skander.
How you doing?
Good. I think we can all hear you really well. Haven't started yet, but everyone can see you.
Okay, but I get to see you and nothing, and be jealous of your shirt and nothing else?
Sorry. Yes, for now. I don't know how.
Oh. Or you know what? Maybe if I join, I can point my camera. the other
Sure.
way.
I have something that connects, so then he
Okay.
try it.
Thank you.
Okay.
For now, it's the sound energy. We'll see if the light energy also.
Yeah.
Yeah. So just want to give you a context of what we have been up to since the morning, and how your experience and expertise can help. So we have a bunch of very exciting folks today, mix of marketing, tech, experience, and till now we were talking about simple models which can help predict whether a user will come back or not using logistic regression and the Google Analytics data. And there were some very interesting questions on how do you know when you have to retrain your model? How do you balance between how much test data you need versus when you want to train your model? How do you balance between the recency of data and the amount of testing data that you need? How do you make sure that the data that you are testing your model is in properly balanced? Of course, all this needs a lot of data analysis and profiling and stuff like that, but just giving you the context on these kind of questions that arose on this conversation. So I thought, I'm not sure if I was able to do justice to all those questions, but I thought listening from you who works on the data science piece and AI/ML piece day in, day out might just be a good TED talk for folks who are really curious about it. So maybe if you want to introduce yourself to the team here and talk about how awesome work you do on the AI/ML piece, and then we just get some ideas from you on how retail is doing in general on AI/ML, and how do you think about the future of marketing analytics with AI/ML, and maybe some of the MLOps piece, that would be great.
Absolutely. So, hi everyone. And if the Circo team is there, nice to see you again, or hear you at least again. My name is Skander Hanachi. I am on the same team as Ankit. I'm based out of Seattle. He is the one of the data engineering specialists on our team. I am the AIML specialist on our team. I've been with Google for about 2 years exactly this June. Before that, I spent 10 years as a data scientist, ML architect, a consultant, DevOps person, basically jack of all trades in the retail industry. Almost, and this is pure coincidence, focused on fashion retail with a couple of exceptions in for Petco and also for electronics retailers in Europe. Other than that, it's been pretty much fashion most of my career. So fashion, retail, demand forecasting, and inventory is basically my specialty. Obviously, that ties into marketing analytics as well, and I have a personal opinion that treating those as separate topics is not healthy, especially going forward with how digital channels, whether things like purely online retailers are starting to be felt in all sorts of ways in the market in general, and also not just that, but also things like applications like Instacart kind of turning brick and mortar channels into effectively separate digital channels in their own right. Or if you're not in retail, but in something like hospitality or something like the restaurant and the entertainment business, then you start thinking about things like DoorDash and Uber Eats and how they are effectively creating digital channels for your very much physical business distribution model. So I'm going to address a couple of the questions. I'll answer them up front just for simplicity's sake, but then I'll try to move to a bigger picture explanation of the topic. So for things like how often should we retrain, how do we figure out the balance of the data, etc. Often there are ways to do so with advanced statistics and data and ML techniques, specifically the whole upcoming discipline, emerging discipline of MLOps. Things like monitoring skew drift, monitoring data drift, concept drift, attribution drift, all kind of pretty involved technical approaches to seeing what your data looks like and trying to use that to figure out how you retrain. Oftentimes, however, it is a lot easier to start with some basic business and domain expertise considerations. They will get you to a place almost as good as whatever the most advanced skew drift and model monitoring techniques will get you to, but a lot faster. So case in point, in demand forecasting, the sales happen every day. Typically a brick and mortar retailer will need to send new purchase orders to their suppliers once a week or once every 2 weeks. They'll also, by the time they've gathered all of their sales from the different stores, from the different point of sale systems, into one central data warehouse, that's probably going to be at a weekly pace. And for a lot of their items outside of very, very basic products like milk and butter and white t-shirts and razor blades and whatever, a lot of them are going to have sales that are too sparse, so there's not going to be any significant information happening day over day. So from that, you figure out that you should retrain your model once a week, not bother doing real-time retraining based on sudden shifts in demand or anything like that. You can get there eventually, and you should in some cases, especially if you have a strong e-com presence. But for brick and mortars, that's a very good starting point, and your business is going to be your best guide for that, not some PhD in machine learning from Stanford. So that's the direct answer to those questions. Now, let me try to present. Am I able to present or do
Yes,
I have
you are able to present.
Let me go a little bit deeper now into what that looks like from a data science perspective.
Do you sorry, do you also want to bring your camera a little bit so that we see your face more, or is it's getting a little cut? Yeah,
Sure.
that's perfect. Thanks.
So some of you might have heard the term MLOps. Others probably haven't heard of it yet. It's causing a humongous amount of confusion globally, and especially here on the mainland. In part because it is a compound buzzword, a triple buzzword even. It involves machine learning, which everybody's buzzing about. There's a new trend in the industry to take just about everything and add the word ops to the end. So there's DevOps, there's product ops, business ops, FinOps, or
Data ops.
incorporate data ops, AI ops, which for some reason is different from ML ops, security ops. At this point, I would challenge anybody to come up with some new flavor of this just for fun. And then ML ops ties a lot to containers and Kubernetes, which is underlies pretty much all of cloud technology this day for all cloud vendors, not just Google. And so between those three, people can be somewhat skeptical of whether MLOps is really a thing, or whether it's just like the old way of doing operations in any IT or business process context, and we're just reframing it because of the new tech involved. So I'm gonna try to give an intuition on what that is, and then tie it to like the bigger picture considerations when you're trying to solve a data science problem or build a data science practice in general in your organization. So, Ankit walked you through the EQML modeling approaches, so you're probably at this point familiar with what an ML model process looks like. You take data, you choose which algorithm you're going to use, you train the model, then you use that model to make predictions on data that it hadn't seen during training. This is kind of the way that people in research, in academia, or also like in consulting firms who, all they do is just come in and do one, insight type consulting engagement, and then they, once they've done their prediction or their insight, they just, go jump to their next project. Or, if it's like a really long-term prediction, like a 15 years ahead market forecast type effort, then you follow a process pretty much similar to what Ankit just shared, where you choose your modeling tools, whether it's Python, whether it's R, whether it's BQML, whether it's a dedicated specialized software for forecasting or for modeling some type of business specific use case. Then you generate your predictions. You do all of the steps, of training, testing, evaluating. Then you generate your predictions and you wrap them up in a bunch of visualizations and some tables. You probably, provide the raw CSV prediction files along with it, or a spreadsheet or something. And you publish in, whether you're submitting to Kaggle if you're competing, or if it's research, you write a research paper or a white paper if you're in a consulting role, something like that. You might publish it as part of your graduate school studies or a PhD. And that's great. The problem is, since so many industry data scientists come from an academic or consulting background, in my case both, we tend to bring that mindset with us to industry. And like, our job is to do everything you see on the left. That's why you hired us. And we're not IT people. We're just, going to take whatever we generated from our data science research effort, and we're gonna throw it over defense. A ex-colleague of mine from Nordstrom, Mike Wihara Bingen, actually came up with this term, the throwing models over the fence model deployment process. Where whatever came out of your research, you just now put in a folder somewhere and tell the IT team to pick it up and go figure out how to turn it into a production pipeline that doesn't require, so that business can use it without having to come all the way to you and listen to you say data science deep speak. Now let's look at what happens if we were to apply a propensity modeling they're applying to a customer churn model as well. Just about any model, but propensity modeling is pretty intuitive and you can do it in BQML, so this one probably makes sense. You have all these data signals coming in. You have a propensity model. It's going to output a probability that a customer will purchase a product or not.
Yep.
Would also, if it's a churn model, it will be the opposite. You know, what's the probability the customer is going to leave your service or platform within the next month or next quarter or something? These are then going to be handed over to business teams who are going to make decisions based off of these probabilities. So, first, very basic version one, where you use only one input KPI or one input feature or signal, is just to rank by, let's say, number of product views. If they've seen that product multiple times, if they clicked on it multiple times, they're probably interested in it, and therefore, the higher the number of views, the more likely they're going to buy. And then you come up with a decision boundary where above X number of views, you tag them as likely to convert. Below a certain number of views, you tag them as unlikely to convert. So, most basic propensity model, while you deploy it to production, you throw stuff over the fence model. And then a few weeks later, you realize that your data pipeline was actually missing one of the sources. So you had views from laptops, you had views from desktops, or from like other types of, home devices, but you didn't have mobile views of the products. And once you add those in, the distribution of the products to conversion rate actually changes. Now you have to update the model again. And then you realize that there was actually product views alone wasn't sufficient. You had to do product views plus bounce rate, or product views plus time spent on the platform in general, something like that. So now you realize you need two features. So you build a third model. Now, an unfortunate fact about ML ops and ML in general is that the best models end up being victims of their own success. In this case, your marketing team realizes that your model is very accurate, starts acting on it, coming up with new incentives, new ways to market the product, to send out promotions. Your decision boundary shifts yet again. You have to retrain the model one more time. Now you are celebrating just how awesome your model is, you're waiting for the promotion, and suddenly the model goes off the rails completely. So in a propensity to buy model, this is something that actually happened to my team in a previous role. We were using the customer loyalty, whether, a binary indicator, did they have a loyalty card with us or did they not have the loyalty card? And the assumption was if they had a loyalty card, they were much more likely to convert. Somebody's loyalty card will look at the product only 3 or 4 times before buying it. Somebody who doesn't have a loyalty card and actually navigating websites from 3 or 4 different retailers simultaneously is probably going to look at the product 30 times before they convert. So that was doing fine, and it was, helping the model be pretty accurate. But then the website team, without telling us, decided to update and streamline the website experience so that you didn't have to input your loyalty number first, then start adding items to your cart. You could at any random time in the process, even at checkout time, you could add stuff, the website didn't even know who you were, and then at checkout time, it said, oh, by the way, do you have a loyalty number? Then you input it. So everybody started inputting their loyalty number only when they had already decided to buy.
Yep.
So what was the loyalty number doing now? Now it was providing what we call leakage or look-ahead bias, basically giving the model an unfair view into the future. What does this mean? This means that in the training and the data science research effort, the loyalty number becomes a perfect indicator of conversion, but then you deploy it to prod and the model goes off the rails completely.
Overfitting, the same example that you were talking about. So, and Skander, sorry to interrupt, but we spoke about, or we did something similar for the models today, where we took the bounce rate and the time on the page to figure out whether the customer would come back. So all this, I hope all this is making sense on in real life production, what we were talking about when we were creating these models in BQML was the starting step to understanding that marketing analytics, data driven marketing analytics has these nuances to it that we deal with day in, day out, or probably Skander does much more than I do. But these are real things that we acknowledge and empathize with, that these are some things that we always see. So Skander, like to a follow up to this, I'll let you carry on, but how do you deal with all this, like changing features all the time and not to celebrate too quickly, or if we have celebrated, how do we go back to sadness and change the models and all that stuff? Like something on the light at the end of the tunnel would also help once you're done with this presentation as well. But
Actually, I
carry
will
on.
address it in the presentation.
Sorry.
Yes.
Yeah.
So you want to get to a point where you don't need a data scientist to solve. So, to put it crudely, this is model babysitting. This is where your data scientist role is, they're acting the way they did in academia when they were doing research and stuff, or the way they were when they were practicing how to come up with awesome models in Kaggle. But from an industry, from a business perspective, you're hiring these relatively expensive resources and very hard to find, type of skill set personas to essentially do model babysitting. Like they're sitting there just making sure that the model doesn't, try to go down the stairs when it doesn't know how to walk yet or something like that. And do you really want them to sit there and just do that over and over and over and over again? No. You want to have an MLOps process in place. So that's exactly what MLOps is. It's trying to get away from this nonsense. It's not nonsense. It's really valuable work, but it's only a starting point. To having an industrial process where the stuff that we know will happen is automatically caught, and the retraining happens automatically. And like I said earlier, that can be on a predetermined schedule based on, business expertise and input from your business stakeholders. So demand forecasting once a week, marketing analytics typically once a month for things like propensity, for things like attribution modeling, customer segmentation, etc. For personalization, like heavy duty, full e-com context where you're doing context dependent personalization. Did the user click on these last 3 products, they probably like this product, and they search for this term, then it's going to be even more than at Northern we did so like every 12 hours or something like that. But you have a constant, continuous retraining. So the concept of training the model now splits into 3 types of training. The training that the data scientist does for research. Continuous retraining that should be automated and doesn't require a data scientist to look at that. Third type of training, which is the same as continuous retraining, but done for software purposes, not business purposes, to make sure that the model won't break the server, won't tax your infrastructure and your compute system too much.
Okay. So basically to summarize what you're saying, there is one training that we do for our experimentation to see what kind of different models are there and profiling. The other training is to actually serve the business purpose of why we are predicting what we are predicting and how model is feeding into the business outcomes to get more customers or do the actual problem solving. And the third type of training is the training where we talk to the software team and collaborate to see how the model is performing and what are the kind of infrastructure resources it's consuming from an overall resource and the back-end development perspective. Okay.
Exactly. And when you do this, you now get to essentially, you're starting to treat it as a real industrial process. You are, however, missing the forest for the trees, because it's easy to do all of that and think that the end outcome of this is still just, improving accuracy of models and making sure that they stay as accurate as possible. And this is something that I'm dealing with day in, day out. It's a weird, it's part of the whole academic mindset, because ultimately a lot of the research is like, oh, our model did better than the previous model that was published 4 years ago. And in order to make it like scientific and technical, they kind of remove all of the business context and focus on benchmarking against a set of well-known data sets. And so they kind of tend to be laser focused, I shouldn't say they, I was one of them for a long time, laser focused on accuracy and missing the big picture. If you had paid attention to the different things that occur during the MLOps cycle, what will happen to, one time the e-com process changed, another time your customer behavior changed. In a churn model, if your churn suddenly jumps up by 50% from 1 week to the next, chances are your competitors are doing something to steal customers away from you. So really, to move away from the accuracy horse race mindset, which is unfortunately still dominating a lot of the community right now, and to the idea that both the modeling process and the overall ML ops process is essentially a signal processing function. Andrew Ng, one of the founding fathers of modern deep learning, said that we have to move from model-centric AI to data-centric AI. Oh my God, not another buzzword. Oh my, no, he really meant something. He was like, guys, grow up. Stop trying to find the most complex neural network possible to improve accuracy by 0.3%. Focus on what signal processing capabilities your modeling allows for you. Do that, and you're still missing the forest for the trees. You're now thinking like a grown-up data scientist, not like a grad student, but you're still just thinking like a data scientist, not like a business person. Your directors, your VPs are going to be a little bit more impressed with the jargon you're throwing. They're not going to be really, really fully bought into how important your work really is. Why? Because this is, everybody's thinking like MLOps model deployment, yes, that is important. But as often as not, the real blocker to AI adoption that we're noticing here in the mainland and in Europe is people don't know how to bring the data scientists into existing processes. And that's going to be as important as anything you do from a modeling and DQML perspective. So this is the an overall high-level representation of a end-to-end merchandising process in retail. And I focus on forecast accuracy. At the other end of this process is the inventory in-stock rates, which is what the planners and the demand planners and replenishment analysts really care about. And then if you go higher in the chain of command, your chief marketing officer, your chief inventory officer really are like, yeah, but those in-stock rates, even those are still really just deep data. I really care about what is the revenue and what are the margins. And there's all these points here which are interfering with whatever modeling capabilities you have. So until you figure out this dilemma, you're really still stuck in the trees and not the forest. So I hope that gives you answer to the initial questions of how do we think about data, how do we think about retraining, how do we think about imbalance, but not from a naive modeling perspective the way most academic data scientists, and again, I am not harping on them, I was one of them for a long time and learned this the hard way. But more how to place this within the context of your business. Yeah. And I will hand it back to Ankit and see if there are any questions.
Yeah, no, thank you. Thanks for sharing experiential learnings and not what we usually see on slides, all pomp and show. So thanks for that. But any questions from anyone? You had a question on there was one question, Skander, which was to me on how do you decide, and I think you touched upon that piece, but your question on volume versus recency was one of that, right? If I'm not wrong. Do you want to ask a follow-up to that? Do you have anything or?
No, I think you explained it.
Okay. Anyone else has any questions for Skander?
I have a question that's more about, I guess, the structure of working with the business, because I feel like one challenge you run into, and you kind of alluded to it, is there's some sort of a structural change in the environment in which you're trying to predict the scenario.
Yeah.
They change something to the website, or a competitor does something. where the analyst, is so busy, heads down, or the data scientist is busy, heads down, to where they're not necessarily aware of that. Without inundating people with like meetings or communications, I mean, what's the best practice to ensure that those, explain to your business partners what's important for the analyst to know and making sure that that information flows?
Sure. Skender, do you want me to repeat that question?
Oh, I heard it.
Okay.
I heard it. So, there is not a specific process practice there. Different companies are going to address it different ways based on how their needs, their available resources, all sorts of things. So in most of my career, I was a data scientist who was fully dedicated to inventory and demand forecasting. And as such, I was directly part of the demand forecasting team. And so these problems would not occur that often, the one I mentioned about the web page. But sometimes I work with more part of a central data science group that kind of acted as an internal consulting firm, and that's where a lot of the whole throw stuff over the fence process would occur, because they are part of a central data science org. They roll up to a chief data officer, chief analytics officer. They bypass both the product teams and the engineering teams altogether in their reporting and chain of command. And because of that, they have to operate in a highly formal fashion. They sit in one floor, they operate in one group, they interact through meetings with their internal customers, the e-com team, the demand planning team, etc. That's where the breakdown happens. It's not so much a skill or modeling problem, it's a organizational problem, that when you have these central data science teams, the risk of those types of things happening is much higher. So how do you solve for it? Last year and up until a year into my tenure at Google, I was very biased on the topic and said, drop that whole central data science concept altogether. It's a recipe for failure, and go with dedicated data science teams embedded directly in product teams or business functions. I realize now that was me bringing my own biases and experience to the table. There are good reasons to have a central data science. The chief among them is resources. Like, you can't afford to have 2 or 3 data scientists embedded in each product function. You also probably, the data scientists themselves hate that, because often there's not going to be new, once you get to mature MLOps, there's not going to be new data science work day in, day out. There's going to be, like, at best 30-40% data science work, and the rest is you're just another DevOps person or another developer, coder on the team, and it can be frustrating for data scientists. So oftentimes they don't like being the embedded data scientists. They want to, did this really cool forecasting thing, now I want to do this propensity modeling thing, now I want to build a recommendations engine. I just read this cool thing about natural language processing. So they want to be part of the central data science. So my answer now is a little bit different. This is not official Google perspective. This is just our own, Western States One tribal knowledge condensed into this answer. So please, the disclosure or whatever, full disclosure, is to, if you want to go with a central data science team, then by all means do so. And you probably have good reasons to do so, and they want to do that. However, make sure that for individual products, they are not sitting in a room doing their data science work. They are literally, for this particular effort for the next 3 months, go sit with the marketing team, go sit with the personalization team, go sit with the forecasting team, go sit with the fraud detection team. At the same desk, you are delegated to them in the same way that a project manager or a business process specialist rolls up to a different org, but is dedicated to that full time, and there's no red tape. They make these decisions. Around somebody's desk in the morning, they don't have to set up a meeting 3 weeks ahead to discuss it.
So basically, to summarize, what you're trying to say is that there should ideally be a centralized team, if possible, that is cross-functional, that determines what is the yeah.
Both models are good.
Yeah.
Centralized cross-functional team
Yeah,
or dedicated.
that's one. And the dedicated one is the one where we keep rotating so that people are working with different teams and not just stuck with working with just one team, right? Skander, that's what you're saying.
No, I'm saying, so there's the dedicated one where you're actually part of that team full time.
Oh, okay. Oh, okay. Okay.
So
And
you have
in some
to
cases
say
that is justified.
building like ML ops into your DevOps.
Yeah.
In other situations, you're gonna have a central cross-functional team. What I'm saying is if you want to have a central cross-functional team, then make it directly embedded, not acting as an internal consulting group.
Got it.
Yeah, that's helpful.
I think we have another question, Skander. Yeah, go ahead, please.
Yeah, so I would like to go, to the whole MLOps thing you just described. So do we have with Google Cloud, do we have all those capabilities to build, a modern ML pipeline? And if it's just a yes or no, I'm sure you will need like maybe, if the answer is yes, maybe it's 3 more hours
Yes.
to discover. But is that the case? Is that something you guys?
We do.
Okay.
Simon says yes. I mean,
Yes.
it's a yes.
I'm sorry, here I'm going to go not only away from my just real world experience sharing and not even to like my marketing for Google hat and go all the way to like my hardcore Google identity. We invented MLOps. This was a paper that was published by Google in 2014 that led to the whole discipline being invented. So yes, we definitely have this.
Okay. So, can I ask another
Of course, please,
question?
please.
So that's possibility one advantage for me to use Google Cloud because I can already take advantage of all the tools that you guys are already offering.
Yeah.
I want to be like very concrete. So on what we just saw this morning. So I heard already one advantage of doing my machine learning through Google Cloud. One maybe minor advantage is that I can directly I can directly go and use my Google Analytics data.
Yep.
I don't need to create a new pool or whatever you guys call it. So that's kind of a minor, I would say a minor advantage.
Mm-hmm.
With respect to the deployment, is there a way and is there a use case that you guys can talk about where somebody use the GA data, create like a logistic regression or something, and actually deploy it back as a campaign?
Yep. So
Because that would be like to me the main advantage at our level right now.
and that's the productionization piece. That's the theory of this slide basically, where some folks write their BQML models and export those models as TF models and then do the whole ML ops on those models that are created as part of BQML and then retrain them and stuff. So the ML ops capability that Skander was talking about, the BQML model that you created today, that can be one of the inputs to that whole pipeline.
So just another very complete. So I just did the Google Analytics beginner over the weekend because I didn't know anything about it. So to create a campaign, you have some filter, location, whatever. So is that the case that I could also as an input, I can put a threshold from a score or something like that and use that as a way to deploy a campaign?
Yeah, so I think Skander, I'll let you answer that, but my interpretation is what Francois is asking is like, can we have some triggers or event-based deployments? And I think the answer to that is a yes, right? Like we can deploy the models if it meets a certain threshold or if there is any score that goes up or down, you can predict and deploy and then that can start creating those campaigns. So that's totally possible. But I'll let you throw your magic on that.
So we definitely have those tools. I would probably go a little bit away from the details of we retreated this using base, and more speak to what I have observed So I work in fashion retail. I can share that I work with Nordstrom, which because it's based in Seattle in the backyard of Amazon and Microsoft, is a lot more engineering heavy than most retailers. And deploying a modern personalization capability for like search or recommendations or marketing analytics would have been there, given that they were at the top end of what brick and mortar retail engineering teams tend to look like, would take 6 months to a year in the best of cases. Since joining Google, I have seen smaller retailers with less engineering talent, or who, because of the pandemic, lost all of their engineering talent in one way or another, deploy modern personalization recommendations capabilities in somewhere between 4 to 8 weeks, which I would have said impossible. There's something wrong with that model. No, they deployed it that quickly, and it's a combination of two things. It's a combination of the products themselves, which are designed to be how, like this is just how we can try to make them as easy to use as possible. And then the second thing is going to be, we bring a lot of accrued tribal knowledge to the table more so. Because the products, keep in mind that we have all these products. AWS or Azure might have better products than Google, but that is a catch-up game. At this point, the major cloud vendors are catching up with each other. Whoever goes there 6 months later, the other two big cloud vendors are there. Those individual features aren't really going to be the decider. What's going to be the decider is how we approach this and how we help. And with this, it's really what we bring to the table in terms of tribal knowledge and experience and the types of partners we engage in situations where you want to use a partner that is going to help. That's why I'm seeing these, what I had thought unrealistic timelines before, like we deploy retail search in 4 to 8 weeks. We have like a really advanced visual data-based personalization engine built by a partner, one of our major partners, that can be deployed in 2 months, things like that. I hope that answers the wider concern, but yes, we do have the immediate, also I can quote a success story, this one is public, so I am allowed to quote it. Wayfair now went to being able to deploy a new model in 2 weeks. Anytime there's a new model, and by new model, not just retrain the existing one, but figure out that you actually need new features and you need to use an XGBoost model instead of a logistic regression. They can deploy that in 2 weeks because they're using our MLOps stack.
Cool, thank you. Any other questions from anyone, or do you have any follow-ups, Francois?
No.
Please feel free to.
Thank you.
Cool. Well, wish this could keep continuing because it's so good to listen, just keep listening to this. But
Tell me when you're flying to Hawaii. Love to jump on the plane with you.
yeah, for sure. Or jump out of the plane in the ocean. That's also fine.
That comment is directed at Lance, not at you.
Yeah. And, I mean, for those of you in the room here, and we're talking about this, I am very confident from a Google perspective. We will get Skander here. We'll work with our true team and with all of you directly as well. So if there's any interest, whether again, we'll have Skander out here on a plane and get him out here. And I know what ramen shop he likes, so I think we can get him to come out, no problem. But thank you, Skander.
Thanks, Skander. We'll collate some other questions as well after this session and send it your way, and then probably we can work towards answering those. But thank you for the amazing talk today. Really appreciate it.
Thank you.
Cool.
Okay.
Bye. Thanks. Bye. All right. Back to the basics, I guess. So the second piece that we're going to do is a little bit different, a little bit more abstract, unstructured than the first one where we knew everything. We wanted someone to predict whether they would come back. These were the features. We wanted to see whether geography is impacting, whether other things are impacting. But this model is just like, oh, you take this data and you just give me the clusters. Like, tell me how I can group the data into various clusters, and then I'll decide on my own what I need to do with those clusters. So since it's that school of thought, we usually classify these set of problems into being unsupervised, because we are really not supervising the model to be trained a certain way, that hey, I'm giving you this input data, I'm giving you these input features, you tell me how the features are connected to the actual output label. I'm just giving you the full set of data, and I'm asking the model, with whatever best you can do, just cluster it into various groups and I'll examine those clusters on my own. So that's what the k-means clustering model is. And the output of the input of this model is, of course, the data that we are going to feed it from BigQuery. And the output of this model would be, you would see some clusters of data being created that we are going to see very, very shortly. And then we can discuss how we can use those clusters in our marketing and campaign efforts. Before we go into these 8, if anyone wants to have a break or something, because I know we were on the listening side when Skander was talking, we can start this session in 5 minutes from now if anyone wants any break or something like that. Please feel free to. Yes.
So is this in the pen?
Oh yeah. So if you go up, sorry, if you go down a little bit, I can't see the data set. Yeah. So DS1 is not the data set. So the data set is.
Yeah.
So you just need to update it to.
I did that, and then it said syntax error. So
Got this. Can you remove that fleet petal thing? Just have Raska.classification model.
oh,
Thanks to
this.
Peter, they convinced Crystal
Yeah.
to
Oh, okay.
Sure.
What's that? Yeah. What's his name? Islam? Tosif. Last name is Islam, yeah. Very right.
Yeah.
How
Yes.
can I change these? The names.
Can you click on that?
This?
Yeah.
Just
I don't know whether you can change these names.
says. Okay. No worries. I'm just
I'm just
making
gonna
sure
check.
I
Yeah.
remember.
Yeah. I think if you save the query, the
Okay.
save thing, if you
Oh.
name it, then it might save query, yeah,
Okay.
and then you can
Oh,
change the
okay.
name.
Thank you.
Sure.
Can you link to GitHub or GitLab?
Using
Like
BigQuery?
Using Google Cloud?
Yeah. There are GitLab triggers for various services, Dataflow, for gcloud, for VMs and stuff like that. For BigQuery, we don't have it, but for compute services, we do have links between GitHub and.
Okay, so like if I have my query in GitLab,
Yeah.
Could I read?
Yeah.
Could I run that query?
Yeah.
You
So.
know, like today we copy paste, correct?
Yeah. So we could have ideally run it through the Cloud Shell, but I deliberately didn't want to use the Cloud Shell because I could have connected the Cloud Shell with the GitHub page and linked it with that and had the code here run here. But this would have been like Linux, like gcloud run BigQuery, this. So it would have been very command line heavy. So I just wanted to ease it out for you to have it here, but you can totally run it using the terminal as well.
So GitLab as well, an internal GitLab, can we link that to?
GitHub I know, GitLab I don't know. I'll check.
Okay, for GitHub, yes.
Yeah, GitHub, yes. Yeah. All right. I think we should be okay to start. So for this one, let's start with creating a table. We are going to create a table or do some data engineering to create like visitor ID and then what OS were they on, what were the product categories they bought, what was the product price, and also hits and stuff like that. So let's go ahead and create this table and then we'll look at what this table entails. Here as well, I would request just two things. Please change the dataset name to your dataset name, dot the table name to your table name, and if you've already done so, great. Otherwise, I'll just probably come and swing by and see if someone is having any issues. So the query would be in marketing analytics k-means link, and the folder is create GA360 table. Is there anyone who's running into any issues?
Sorry, where do we have to change things there?
Yeah, no worries. So
the first line.
the first line would be your dataset name dot your table name. No worries. Do you, sorry, issues? Okay, I'll take your guys' lead to proceed further, so please let me know if you want me to wait. But once this table is created, you can see that we have created this table with visitor ID, Windows Phone, like what was their OS, did they buy an apparel, did they do some office buyouts, electronics and stuff, what was the product pricing, and then all that stuff. So basically now we are going to use this data to create groups of customers. Like what does the group of a customer with Windows Phone and all these products looks like? high-end customers, customers who don't spend as much and stuff. We'll look at some interesting groups with this exercise. Let's also go ahead and create another table, which is a synthetic table for basically some CRM level information. We keep hearing from customers that they have Salesforce and all the other CRM information that they would like to bring into these data models and AI/ML models. So let's just look at creating another table. So the difference between the first model and the second model is that in this model we are creating two tables, and we are going to join those tables and stuff like that. We'll do a lot more data engineering that we did before, and we are going to join those tables and then create a model at the end. So this table, let's create it again. Create it in your data set, please, and create it with the name that you can identify later. So I'll probably do we are on step number 2 of this lab, which is creating the CRM table. Oh, what just happened? Oh, my Wi-Fi. Sorry. Oh, is it because our session, are we running over? Yes, I think so.
Time's out right at 11 a.m.
Time's out right at 11. Sorry about that.
It's pretty strict, no grace period.
It's pretty strict, yeah. Oh, yes, of course.
Sandbox guest.
Sandbox guest.
And then the password.
Chamber 2022 with a capital C.
Okay, thank you. Thanks. All right. We'll wait for a minute to see if everyone's able to create those two tables. Is there anyone who was unable to create the CRM table or the other table? Okay. Awesome. Now the third part is, now we are joining the CRM table which contains the fictitious gender of the visitor IDs and stuff like that, along with the main table where we have the buyer behavior, what's the product they bought, and what was the channel and stuff like that. So let's create the final table that will be used for our data models, for our AI/ML models, which will be step number 3. Again, a request here would be to have the data set and the table name. And you can just name it anything like final table with your name or something like that.
So you need to change 5 and 6, correct?
Sorry. Yeah. These two tables as well. Yeah.
So we could have done that earlier today versus repeating predicting the same code. We could have just created that table.
We could have created that table.
Remember, in all the code in the previous exercise, practically we're creating the table of inputs and outputs.
Yeah.
We could have created it there and just called it versus repeating the code in every.
Oh, so basically this, yeah, you're right, absolutely. But this one, just wanted to create this to give a different feel of how CRM data integrates into all this. And this is a little bit of a different data set than that one.
Yeah.
But you're right, we could have done this whole thing preemptively. Yeah. Just gonna, GA360 table Ankit. All right. So now we have our final table that contains CRM data, simulated CRM data, and GA360 data. So we have some data points that would tell us some demographics as well as some usage statistics of customers with respect to what product they used and what channel they used that product from. And yeah, go ahead, please. Oh, sorry. Okay. Yeah. So that was the data engineering piece. Now here, this is just the syntax of creating the model. That's all we need to create the model, which is the k-means clustering model here. And we are gonna simply create this model, and I'll go over one thing that's important here, which is the number of clusters. So just a moment, let me copy my data set name here. Final table Ankit. So to create this, we would request you to make 2 changes in line 1, your data set and the model name, and then line 5, your final table name, which is the data set name dot table name. Those are the 2 changes we'd request from you. Keep everything else the same for now. We will do some interesting stuff with the number of clusters here, but for now just keep it 4. Let's assume that the business told us that, hey, give me 4 groups of the data, just do whatever, but give me 4 clusters of users and we'll figure out what to do with those clusters. So let's assume that's the fictitious problem that we are solving at hand. So you said, okay, give me, hey, BigQuery, create a k-means clustering model for me and create 4 clusters with the final table that I had. And here as well, to your question before when you asked, how do we omit the full visitor ID and stuff, we are just saying select star except. So we are feeding all the data but the visitor IDs, because for every customer the visitor ID will be different. That will not attribute to creating groups and stuff like that. So we need similarities here, not differences among the data. So that's the reason we excluded that piece. Let's run this and see what happens.
Ahead of this, is there any sort of functionality to do, like, I know like using R, using like SAS, is there diagnostics to figure out based on the sum squares, what would be the optimal number of clusters?
Yes, I'm going to go over that.
Okay,
yep.
Cool, sorry.
So yeah, no. To answer your question, we will run this for 4 clusters, 5, 6, 7, and then we will see what's the mean squared error and the DB index for the clustering. And then we will converge to a point where we will be able to say that, hey, 6 is the number of clusters where the DB index and the mean squared error are converging. So that seems to be the best size of cluster for this data set.
Okay, but is it simply trial and error, or can you run something to where it would kind of show the variations? Like I'm thinking, like, I forget the R package, but there's an R package where it will show basically a graph of your number of clusters on the x-axis and the y-axis. Your sum squares showing basically as you add more clusters that
So BQ doesn't have it, so we do it trial and error wise. But usually the clusters that I have played with is between 4 and 9 and 4 and 10. So I just create, I have to run it like 5, 6, 7 times and then I'm done basically. Yeah, BQ doesn't have that library, which actually, even without you running these models, knows beforehand that if you run 5 clusters, then your DB index will be this much, and stuff like that.
Could you like run a loop of
do
it, create a database, and then he can go and read the database, and do.
You can. I could have run this query in another console as well with cluster size 5, with cluster size 6. So just like invoking the creation of model with a loop with the input as the number of clusters. Yeah, totally. You can totally do that. So now we have the, sorry, where's my model? This one, this is the model. Or am I using someone else's? No, this seems to be the model. So if you see this, we have 4 clusters created for us. 1 cluster with 4 groups created for us, and this is the information it gives us. There is a group 1 with most of the people in that group basically, which are low on apparels, low on bags, absolutely minimal on electronics and stuff like that, and the product pricing for them is some cents and stuff like that. So that's the most of the customers. And then if you see, there are 53 customers in Centroid ID 4 or in group 4 that buy the most of the apparel, the most of the bags, most of the limited supply. So these are your these are those kind of customers, but their product price average is about $1 or something like that there. And then you have some customers which are most expensive ones, like they spend the most on products, but they spend the most on bags basically, maybe because the bags are the most expensive. I don't know too much about fashion, but that's what it seems like. So now with this is what you get as the output, and this is what you figure out to see, hey, what do I do with customers who are in group 1, for example? What do I do with customers who are in group 2 and 3 and 4 and stuff like that? So this is the kind of insight it gives you. Now, my personal favorites are a lot more the supervised ones, because there is a structure to them and I know what I'm getting at. Here it's all a little bit abstract, that I know, okay, these are the groups. I really don't know why group 2 has most of the electronics and Y group 4 has most of the limited supply, but I know that's the case. That's all I know from this model. So that's what this model gives you, and this model has a DB index of 1.3 and a root square distance of 8, which is I think a little bit higher. So basically we try to have the number of clusters where both these values are low, 1, 1.5, 2 or something like that, and I'll show you that piece. So what we are going to do is we are going to adjust some number of clusters and also see if we can add some features to it to see if we can either bring down the root mean square distance or the DB index or both. So let's see if we can do, sorry?
No, we don't have the same number, correct? Everybody has a different number. Yeah.
Yep. Yeah, because this is an unsupervised model, yeah. So we'll try to see oh, I think I jumped the gun and update and rename, create 3 to 4 segments. I did 4 segments. Let's see if we create 6 segments, what happens to this. So if you just want to change the number of clusters here and have it stored somewhere where you know that this is the model that had 6 clusters and this is the model that had 4 clusters. Let's just create another model with 6 clusters now. Yep.
So what do you mean when you say the model is unsupervised?
Sure. So basically when we were talking about the previous model, and a comparison might really help you. In the previous model, we had a final goal that we need to predict whether a customer will come back or not, right? And we told that that's what we need the model to learn based on the features that we gave, geography and the bounce rate and stuff like that. So we supervised the model to train the model on, we gave the model a supervision that this is your test data and you need to get it to a point where you are able to predict whether a visitor will come back or not and stuff like that. So there was a correlation between the output and the input in some way. Output is called the label in data science, and then input are the features. So if you think about that as a mathematical equation, a supervised model is nothing but a mathematical equation that says the output is a function of the inputs with a certain degree, like x square of input plus y square of input equals z square of output or something like that. So the model tries to come up with that equation because the model's whole and sole goal is to predict an outcome that you want it to predict using the input that you give it. Here, I didn't ask the model to do any kind of label prediction that, hey, you have to tell me what's the likelihood of a customer buying this apparel or something. I just told, take this data and just make it in different clusters. That's all I told it. So I didn't teach the model or train the model to do some kind of supervision on a label or something like that, which I did in the previous model. That's why this is called an unsupervised model. Wherever you have to define a label that train my model to predict X, Y, Z, that's a supervised model. Here I'm not doing any of that. I'm not telling the model to predict something, something, something. I'm just saying, just give me a cluster. I'll take care of what I need to do with that cluster and all that stuff. So that's what the prediction means. I think my model with the number of clusters as 6 it seems to be ready. Let's see how it is working. To both your point though, I could have done these things in parallel or in a loop, in a for loop and stuff like that, and then done it. So if you see here, my sorry, where is my model with the 4? Yeah. So there is slight improvement where my mean squared distance between the, am I not able to, yeah, my mean squared distance was 8 before, and now my mean squared distance is 6.9, and my dB index has sort of been the same. There's a little bit of variation. So I am improving on my model, and why I'm saying so is here these concepts, what they mean, I'll go a little bit on this. Let me actually show you why they might be important. So mathematically, the clustering model is like, these are the clusters. We had 4 clusters, now we had 6 clusters and all that stuff. And the mean squared distance in simplest terms just tells how closely clustered are these points for a given group of the clusters. So if you see here, this cluster is the best, because here if you consider this as a center, there is a lot of grouping or crowding that is happening. The more crowded the group is, the better it is. Here if you see, you have a lot of points outside. Like if you consider this as a center, you have a lot of points outside. So there are some points here that are concentrated, but there is a lot of distance between these points and stuff like that. So this is a cluster, but it's not that great basically. And here as well, you see there's a lot of these outside points and stuff like that. So if your mean squared distance is low, that means that the points in a given cluster are very, very closely tied to each other, which means that it's a good cluster. And the dB index, on the other hand, means how far are these clusters from each other, basically, how different are they. So one is an intra-cluster quality check, which is the mean squared distance, which is within the cluster, you see how close families are or stuff like that. And one is the inter-cluster quality check, which is like, hey, how far is the red cluster from its neighboring cluster and all. Now both, the lower the value of both, the better it is, because if this is lower, you know that cluster with elements within the cluster are closely tied, so it's a strong knit group of family of dots. And this one being low means I don't have too much similarity between the clusters, so I can mentally segregate that cluster 3 really means I have XYZ features in it, and cluster 4 really means I have ABC in it. So if there is more and more similarity, you will be confused, then why did the model create 2 different groups? Then it could have been a similar group of disparate points. So that's the goal. So if you see, we were able to reduce the mean squared distance in clusters 6 from cluster 4, which meant that like we are bringing the dots together and making it a better group. If you do 7, 8, 9 and stuff like that, you'll be able to see that how these values are changing. And usually what we do is we create a graph of that and see where those values converge basically, which means if there is a converging point between the dB index and the mean squared distance, we know that one of them will start to go up from there, and one of them will start to go down and stuff, and then it becomes a business decision what to do. But usually where they converge is the number of clusters we try to sort of make as the authoritative point of view, and these are the number of clusters we need. So we could have gone ahead and did it for 7, 8, 9, 10, 11 and 12 and stuff like that, and then figured out like what's the best number of clusters that we want. I was wanting to show you a graph that I created with the same thought, but I'm just not able to get it. Let me check if I can quickly see if I can get it. I think it was model quality evaluation or something. Yeah, this is the one. Yeah. So if you see here, I actually ran this all using the for loop that you were saying in Python basically, and and I use that for to invoke these BigQuery models. So this was for one of the models where I was creating a graph between DB index and the mean squared error, and after 5-ish clusters, I would see that the mean squared error was going down, which was great, but the DB index was coming way up. So we decided that we'll probably keep our models to have 5 clusters basically and stuff. So this is a simple way. I ran it for 10 iterations and stuff like that. So so that's how we came to, we thought that 5 is fine. So that's how it was. So that's a way to sort of think about this. So you don't need to run this piece, I guess, because we already saw it in the UI. What's the DB index and what's the mean squared error? If you run this query, you'll just get those two in form of a query response. So this is absolutely fine. Now, if we created 9 segments, for example, then we can just create them and see what would be the DB index and stuff like that, but it would just say what would it be and how good the model would be. But what I would want you to do is to run this last query basically, which is folder number 8. I want to show you what it gets you. So with your segmentation 6, you can probably just run this simple query. Final table, Ankit. So this is nothing but it just gives you the output of that same thing. This is the cluster and stuff like that. So basically this is nothing but the visual form of these clusters, which can help you identify your business strategies and stuff like that. So that's all to this lab. If there are any questions, let me know and stuff, but that's all that was there to this one. This one was a little easier because we didn't have any supervision to do and train the model first and stuff. It just created these clusters and then it would help you out and stuff like that. So yeah, so that's what this one entails. And I think the most important things in this model is to consider that your number of clusters should honor what kind of DB index and mean squared values you want it to have. And you can do the same exercise that I did, where you create like these iterations and then you figure out what is the exact combination of the DB and the number of clusters you are okay with. Sometimes having too many clusters might give you like a very low number on the mean squared and a very high number on DB index, and it might be confusing on like there are so many clusters that it might become difficult for you to mentally differentiate what exactly segregates one cluster from the other. So this is also a very abstract exercise, but good to do. So you can do that. I'm going to share the Python for loop code for this as well as an extra step. I'll share the Git link for how do we link the Git queries to actually run using the gcloud for BigQuery, if that's going to be helpful to you.
Say that again?
I guess you wanted some Git integration to run the queries directly using gcloud, right, without copying them.
Sure.
so I can share that piece. And I'll share everything that we ran today, all the queries, all the Git links, all the slides and stuff like that, so you guys can have an offline read of that. But I think officially that concludes the session. So thanks for being the awesome audiences. But that's all I had.
Thank you.
Thank you so much for having me. Yeah.